Hi guys, I Aziz welcome you to CoedMaster, and in this video we will see what are the different ways to create ArrayList in Java and what are the operations we can perform on ArrayList in Java. So make sure to watch this video till the end. So let's get started. Alright, let's begin this video with the first way to create ArrayList in Java. So the first step to create ArrayList is to import ArrayList from java.util package. Now once the ArrayList is imported, we are good to go to create the ArrayList. How to create an ArrayList? The syntax is ArrayList al is equal to new ArrayList semicolon. So this is how you can create ArrayList in Java. This is the simplest way to create ArrayList. So what it does, it's going to create an empty ArrayList of size 0 with some capacity defined in the implementation. So this was the first way to create ArrayList in Java. Now let's see the second way of creating ArrayList in Java. So the second way to create ArrayList in Java is like this. So this is a syntax to create ArrayList by passing initial capacity in the constructor of the ArrayList. You may ask that why we are passing initial capacity in ArrayList. Without initial capacity also, our ArrayList is working fine. So the reason is, with initial capacity you can avoid the unnecessary reallocation. Okay? Because when ArrayList grows internally, it reallocates all the elements present in the existing ArrayList to new ArrayList. So if you know the size in advance, then you can avoid all those unnecessary reallocation. So guys, for those who don't know what does it mean by reallocation, I have created a video in which I have explained in detail that how internal ArrayList work. So if you have not watched that video, then I highly recommend to watch that video. Come back here and continue watching this video. Okay, so now back to ArrayList. So now let's see the third way to create ArrayList. So the third way to create ArrayList is we can create ArrayList using the existing collection. So here we already have this collection present in the code. So here we have ArrayList and we have 3 elements in this ArrayList. So by using this ArrayList, we can also create new ArrayList. So we can write ArrayList al2 is equal to new ArrayList and pass it, and here we can pass already existing collection in the constructor of this ArrayList. So let's verify it by printing the ArrayList on the console. We will see 543. Okay, so this way we can create ArrayList using the existing collection class. So these are the 3 ways we can create ArrayList in Java. So the first one is this, without passing anything in the constructor, and the second one is passing initial capacity in the constructor of ArrayList, and third one is passing existing collection in the constructor of the ArrayList. Okay, now let's move on to the next section of this video where we will see what are the operations we can perform on the ArrayList. So after creating ArrayList, the first method we can call on ArrayList is al.add method. Now you can see that there are 2 variations of add method here. First variation is taking object as input, and second variation is taking index and object as input. So let's try the first variant, that is taking an object. So let's try the first variant, that is taking an object. So let's do al.add and give it an object, that is 5. Okay. Now let's add few more elements to it. 5, 4, 3. And now let's verify it by printing it on screen. So we have 3 elements in the ArrayList. Okay. Now the second variant of add function takes index and object both. So we want to add element at index 3 and the object is number 2. Let's verify it. So now we have 4 elements in the ArrayList. Okay, so far so clear. Now let's move on and see other methods we can call on ArrayList. So the first method is size method, S-I-Z-E. It is giving 4. So the size method is used to get the size of ArrayList. So do not get confused between capacity of ArrayList and size of ArrayList. Capacity is the total number of elements the ArrayList can accommodate, and size means the number of elements that are present in the ArrayList at a moment. Okay, let's see the next method, that is empty. So isEmpty method is used to find whether the ArrayList is empty or not. Let's verify it, and it gives us false because ArrayList contains 4 elements. Now let's see the next method, that is get method. Now get method takes index as input. So if we pass index, let's say 2, it will give element present at index 2, and that is 3 because element 3 is present at index 2, because 5 is present at index 0, 4 is present at index 1, 3 is present at index 2, and 2 is present at index 3. So let's see the next method, that is set method. And set method is used to set element at a specific position. Means we can update the element at its specific position. So it takes index. So let's give it an index 3. And let's set the element at index 3 is equal to 1. Okay. So let's verify it. So right now we have 5, 4, 3 and 2. Then we are updating element at index 3 and making it 1. So it should print 5, 4, 3 and 1. Let's verify it. And this is it. Okay. So we get 5, 4, 3, 1. So this is all about set method. Now let's see the next method of the array list, that is index of method. So what it does, it simply returns index of a specific object. So let's pass it object that is equal to 2. So in return it gives index of element 2 and the element 2 is present at index 3. This is correct. Now let's see the next method, that is contains method. Okay. So contains method takes object. So we have to pass it object. So let's give it an object integer dot value of 3. So it checks whether 3 is present in this array list or not. And this time it is. So it should give, so let's verify it. It is giving true. This means 3 is present in this array list. Let's give it some invalid value. Let's give it 13. So in case of 13, it simply returns false because 13 is not present in this array list. So far so clear. Now let's move on and see the next method, that is remove method. Okay. So in remove method also there are two variants. The first variant is taking index as input and second variant is taking object as input. So let's try the first variant, that is with index. So let's pass it index 3. So hopefully it is going to remove element at index 3. Okay. Let's verify it. Run the program and see 5, 4, 3. 2 is removed from the list. Now let's see the next variant of this remove method, and that method takes object as input. So let's give it an object integer dot value of 3. So this time it's going to remove element 3 from the array list. Boom, we get 5, 4, 2. 3 is completely removed. Now let's see the next method, that is toArray. So toArray method is going to convert the collection into array. Let's verify it. Oh, what it is giving? I think it is giving address of class because arrays in Java are classes. So what we have to do, we have to convert this array into string. So to convert this array into a string, we have to call arrays class, arrays. Okay, and it is present in java.util package. Arrays.toString, by passing it a l.toArray, it's going to convert this array into string. Now let's verify it, run the program, and boom, we get the elements on the screen 5, 4, 3, 2. So far so clear. Now let's see the next method, that is sort method. Okay. So let's call al.sort. So this is going to sort all the elements. So currently we have 5, 4, 3, 2 in decreasing order, and now we have to sort this element in increasing order. As you can see here, sort is asking comparator. So let's give it comparator. Okay. E1 is the first element, E2 is going to be second element, and give it E1 minus E2. Okay. Now let's verify it by printing elements on the screen. And here you can see that the elements are arranged in increasing order. Okay. So this is how sort method works. Now let's see the next method, that is clear method. So what is the job of clear method? To clear all the elements from the array list. Let's see it. Okay. You can see here we get blank array list. So all the elements are cleared from the array list. Now after all these methods, let's see the last method, that is ArrayList dot ensure capacity. Let's give it 100. Now here you may ask, what is the use of ensure capacity? So the use case is exactly same as initial capacity. If you know capacity of ArrayList in advance, then you can use ArrayList dot ensure capacity, so that by default ArrayList preoccupied space for 100 elements in the memory. So due to these, you can avoid unnecessary reallocation of array elements. So this is all about different ways to create array list and what are the different methods we can perform over array list. So I hope guys now you understood that how many ways we can create array list in Java and what all operations we can perform on the array list. So now it's time to move on the notepad and see what are the time complexity of all these operations. So the first operation we have performed is add, and we have seen two variants of add method. So the add method simply takes big O(1) amortized time complexity to add elements in the array list. Okay. The second method is isEmpty and size. These both method takes big of one constant time to check if the array list is empty and to check the size of the array list. Okay? And why is it happening? Because in array list, it maintains a variable internally and that variable keep track of number of elements present in the array list. So that is why the size and empty function is taking big of 1 means constant time to check the array list is empty or not and the size of the array list. Now the second method we have seen is get and set method. This method also take big of one constant time to get the element and set the element, and this is because array supports random access, so we can access any element in constant time. So far so clear. The next methods are index of method. Index of method returns the index of the specific object. So to find the index of specific object, it has to traverse all the elements of the array. That is why it takes big of n time to find the index of the object. Similarly, contains method also has to traverse all the elements to find the element is present in the array list or not. Similarly, remove and remove, all methods take big of n time complexity to find the element or remove the element. Now the second function is toArray. To convert all the elements into array, obviously it has to traverse to all the array, that is why the time complexity is big of n. The next method is sort method. The sort method takes n log n time to sort the elements in the array. Okay? In worst case, it takes big of n log n. Okay? And the last but not the least is the clear method. This clear method is used to clear all the elements in the array list, and to clear all the elements in the array list, it has to traverse to all the elements to mark it as null. So that is why the time complexity is big of n. So guys, I hope you have understood the time complexity of all the methods by now. So guys, if you have learned something valuable from this video, then please hit the like button to make YouTube algorithm happy, and subscribe to this channel, and don't forget to click the bell icon so my friend you never miss any upcoming videos. So this is all from my side. Thanks for watching. See you in the next one.